In this section, we're going to learn how to count the atoms of molecules using the chemical formula. The chemical formula gives us the information about what elements are present and how many of them. Let's take a look, for example, at this first example, sodium carbonate. The good news, you don't have to be concerned about the name of the compound. In fact, you'll be learning how to name compounds primarily in grade 10 and in more detail in grade 11. So the first step is to take a look at the chemical formula and identify which elements are present. So we use the periodic table as our guide, and we see the symbols Na, C, and O. The symbol Na stands for sodium. And in this equation, there is the number 2 as a subscript beside the sodium. This subscript tells us that there are 2 atoms of sodium in one molecule of sodium carbonate. The next chemical symbol that we see is the letter C, and this stands for carbon. Now, in the chemical formula, there's no number or subscript beside carbon. When this is the case, we make the assumption that there is 1 atom of carbon in one molecule of sodium carbonate. The third chemical symbol that we see in this chemical formula is the letter O, and this stands for oxygen. The subscript beside the letter O is the number 3. This tells us that there are 3 atoms of oxygen in one molecule of sodium carbonate. The final step is to determine the total number of atoms present in one molecule of sodium carbonate. To do so, we add all of these atoms together to find the total number 6. In the second example, calcium phosphate, we see that there are brackets surrounding a group of elements. In this case, the symbols P and O standing for phosphorus and oxygen. When we see brackets, we have to apply a special set of rules. We're going to apply the distributive property and multiply the subscript outside of the brackets by the subscripts of each of the elements inside the brackets. So we will be multiplying the number 2 outside the brackets by the number 4 associated with the oxygen and the invisible number 1 associated with the phosphorus. So let's get started in answering this question. Let's list the first element. The symbol is Ca, and this stands for calcium. Next we have the symbol P, and as we mentioned before, this stands for phosphorus. Finally, we have the symbol O, and this stands for oxygen. So let's fill in the number of atoms. There's a subscript 3 beside calcium, so there are 3 atoms of calcium in one molecule of calcium phosphate. Phosphorus has no subscript, so we assume that there is 1 phosphorus, but we're going to multiply this by 2, the number outside the brackets. So 1 times 2 is 2 atoms of phosphorus. The number associated with oxygen is 4. We'll multiply this number by the number outside the brackets, which is 2. 4 times 2 is 8. So there are 8 atoms of oxygen in one molecule of calcium phosphate. Let's find the total number of atoms by adding 3 plus 2, 8. This is a total of 13 atoms in one molecule of calcium phosphate. In the third example that we'll look at, 3 barium chloride, we see a number 3 in front of the entire chemical formula. This number 3 is called a coefficient. Whenever you see a coefficient, you know that there are actually that many molecules. So in this case, there are 3 barium chloride molecules. So you can go ahead and multiply your answers to the number of elements by 3. So let's start answering this. The symbol Ba stands for barium. Next we have the symbol Cl, which stands for chlorine. So let's go ahead and count the atoms. There's no number beside barium, so we assume the subscript 1. So there are 3 times 1, which is 3 atoms of barium in 3 barium chloride. The number beside chlorine is 2, so there are 3 times 2, which is 6 atoms of chlorine in 3 barium chloride. 3 plus 6 is 9, for a total of 9 atoms in 3 barium chloride.